So with scale factor, okay, what we're focusing on today is when you have a copy of a figure of a certain size, for example, 150%, how does this affect the measurements of the new figure? So the sheet of paper I handed out to you, which kind of looks something like this, right, has the original drawing, which is in the middle for you guys, right? And then the 75%. What do you notice about the drawing that's 75%? It's smaller. And then there's one copied at 150%, which obviously you see is bigger, right? So we got some new words to learn today. Corresponding sides. Again, that's sides with the same relative position in the figures, but obviously they're not, and the sides are proportional, but they're not the same length, right? We talked about the figures yesterday. We doubled, right? Those were not the same size. They look the same, right? If you looked at the triangle, you could see where the flat sides were, where the diagonal was. One was just bigger than the other, right? Corresponding angles. Angles that have the same relative position and similar figures in the same measure. So again, a triangle, you saw where the 90 degrees were on both angles, right? They're the same angle. It's just bigger sides. And then naming the angles. We're going to talk about all that stuff today. Excuse me. So down here, we have two triangles. So when we say corresponding sides, like AC and DF are corresponding sides. Right? AB and DE are corresponding sides. And BC and EF are corresponding sides. That means they're basically on the same part of the triangle. They're just not the same what? Length. One is bigger than the other. Now, angles, obviously angle A and angle D are corresponding angles, right? Because they're both right angles. B and E are corresponding angles in C and F. Okay? So if I wanted to call an angle that included angle A, right, we always use the middle part of the angle as what we call the vertex, meaning where you would put your angle ruler to measure the angle, right? So if I wanted to call this angle A, we could actually call it angle BAC or angle CAB. Because the middle letter is really where the angle is. These two guys, B and C, are basically kind of the endpoints of the angle. So remember in the very first book when we were drawing angles and measuring them, so that middle point where we put our dot on, that's got to be the middle of the angle. So basically these letters are kind of the endpoints of our angles. Okay? So again, if we're trying to find angle A, this is how we want to word it as. Okay? Make sense? All right, so let's turn the page. There's our little intro. So, Daphne thinks the rubber band method is clever, but she believes the school copier can make more accurate copies in a greater variety of sizes. She makes a copy of the Super Sleuth with the size factor set at 75%, and she makes another copy with the setting at 150%, and the results are shown below. There are pictures. So when we get ready to do this, a few things we need to know, right? Area formula, which is length times the width. That's for any square or rectangle, right? And you also need to understand the area of a triangle, which is half times the base times the height. So basically, if you had a triangle, there's the height of it, and then the base is the bottom part, right? We're going to need those as we go. So if I copy something at 75%, how can we write 75% as a decimal? Blake? Exactly, 0.75. Remember, percentages are not numbers. So 75% is less than a whole, right? A whole is 1. So that's why the decimal is always less than 1. If it's bigger than 100%, that means it's greater than the whole. So what do you think 150% would be written as a decimal, Aiden? 1.5. Very good. All right, so with your team right now, I just want you guys to work on part A. Okay, 1 through 4. And so basically says here, for each copy of Super Sleuth, using your tools, answer the following. So describe how the side lengths compare to the corresponding sides of the original figure. So for this guy and this guy. All right, they want you to answer both copies. Then they want to talk about the angle measures, perimeter, and then remember on the back, number 4, ask about the area. We actually did a similar problem yesterday, right, with area. We talked about how it changed when we doubled it. All right. So if you need to refer back to your notes from yesterday, go ahead and do so. So as a team, I'll tell you what. Do you guys want to pair up? So there's 4 of you, or you just want to work 2 of you? All right. Why don't you guys come over here, Braden and Lily? You can sit there. So now we got groups of 4 today. All right. So we'll give you a little bit of time to work on part A. There's 4 questions to answer. Okay. So see what you can do as a group. We're gonna pause the video here and let you work. Shh, folks, bring it back. So, what did you notice about the side lengths of the copy that was 75% to the original? Side lengths, Blake? Right, it's 25%. So if it's 25% smaller, the lengths are 3/4 times the original. Because 75% is, or 0.75 is 3/4, right? So it's a quarter smaller than the whole, right? And then obviously the side lengths are how many times bigger in the 150% copy? How many times bigger? Which is how many times? We wrote the decimal down. 1.5. I'll spell original here in just a second. There we go. So, and again, notice that 3/4 is less than 1, right? Because again, if we have the whole at 100%, 100% as a decimal is 1.00, right? So if the fraction is less than 100, that means it's smaller than the original picture. Notice that 1.5 is bigger than 1.00, right? Which that shows you why the drawing is bigger. Does that make sense? Question? Wouldn't it be like it's 5, like 50% or 5? Well, it's 50% bigger than the whole, but it's 1.5 times the size of the original one. Like, if, for example, if you had a side length of 8, to find the side length of the bigger one, you have to multiply it by 1.5, not 50%. 1.5. So, what do you know about the angles then on each of the figures? Were they, Ava? Yeah, the angle measures are all the same. Because it doesn't matter how long the side lengths are, it doesn't change the fact that it doesn't change the angle measures at all. At all. All right, so what would happen to the perimeter then? We talked about yesterday how the perimeter changed in the side of the shape that we doubled, right, with the 2 rubber bands. So what would happen to the perimeter in the 75% copy? I'll give you a hint. It's similar to the first answer in part A. Lily? It would be like 75% of the original. Well, try not to use the percentages as much. What's 75% as a decimal? Yeah, it's basically 3/4 or 0.75 times the original perimeter. It's smaller. Now, Ain kind of asked the question before, why don't we just multiply it by 1/4? Because if you multiply it by 1/4, you only find the difference. You don't find the actual distance. So if it's 3/4 smaller, if you multiply whatever that number is times 3/4, you'll get the actual length. Where if I multiplied it by 1/4, you're going to get kind of, well, it is so and so inches smaller than the original. You're not going to get the exact length of the side, okay? Which is why we multiply it by the fraction or the decimal. Right, but they're trying to find the length of it. And then in a 150% copy, obviously the perimeter would be what? Perimeter is what? If this was 3/4 times smaller, what's the perimeter in the 150% copy? 1.5 times the original. So it's not really, it's kind of halfway between doubling it and the original size, right? 1.5? Because doubling it's 2, right? Right? We did that yesterday with the drawing. All right, this is the one that everyone seems to struggle with. All right, so remember, perimeter and area are not the same thing, right? Area is length times width, right? So if you talked about the perimeter, which means if the length is 3/4 the size of the original one, right? And perimeter is an area is length times the width. You need to take 3/4 times 3/4. What's 3/4 times 3/4? Who remembers how to multiply fractions? Maria? Yeah, you multiply straight across. So 3 times 3 is 9, and 4 times 4 is 16. So the area, or the new area of the 75% figure, let's just finish this up. We'll wrap this up on Monday. It's 9/16 the size. We'll finish this up on Monday. Have a good weekend.